Welcome. My name is Christopher Skack, and I am a product engineer for the Tektronix Source and Analyzer product line. The AWG software team has developed several AWG plugins that enable AWG users to create test setups that will improve their overall efficiency by shortening the time it takes to build these complex application setups and waveforms. As you can see in this slide, we are actively supporting several specific application areas where AWGs are heavily used, such as HighSpeed Serial and communications, advanced research, radar and electronic warfare, and optical and networks. So we have specific plugins that enable each of these applications, and today we'll mostly be talking about the HighSpeed Serial and capabilities. And this includes the capability of running on Source Express, the HighSpeed Serial actual plugin. Also, we'll be talking a little bit about precompensation, S-parameter plugin, and spread spectrum clocking capability. And then in some cases, some customers are also using our RF generic plugin, but I won't be describing that as much today. The plugin architecture enables us to build these plugins more rapidly than creating separate applications, and allows the plugin to be installed right into the AWG or in Source Express, as you see here. We are actively working on new plugins for specific applications most often requested from our customers. As I mentioned, today I will be talking about HighSpeed Serial Waveform Generation plugin that's specifically for our AWG 70000 series AWG. This plugin is an update from our previous software called Serial Express. It has all the same features as Serial Express, but we built it into this architecture such that it's built right into the AWG itself or through Source Express, thus not requiring that you run a separate application. Serial Express has been a very popular tool for creating specific serial data waveforms and setups that enable serial data designers and engineers to do complex receiver testing on their high-speed serial products. This plugin takes all the features of Serial Express and packages it into an easy-to-use plugin that can run directly on the AWG or remotely using our Source Express PC software. This architecture removes the need to run separate application on your AWG or PC, thus improving compilation speed and ease of use. We have also streamlined the waveform generation process, so building complex compliance and margin test waveforms is an easy task and doesn't require the user to have intimate knowledge of the AWG hardware and how it works. These plugins are available from Tek.com as a free download and can be licensed to run as a trial for up to 30 days or purchased with several licensing selections. So let's get started with the demo. Okay, here we're showing Source Express, and in Source Express it's basically looking just like the AWG user interface looks. So we have basically the same headers as we see in our AWG. Everything else is identical. So the nice thing about Source Express is you don't have to learn something new. Basically it's exactly what you see on the AWG. The only difference will be is that you see over here under the generator list. With Source Express we can have a virtual generator, so we don't actually have to be connected to an AWG. Or if you do have a connection to an AWG, you can have as many AWGs as you want connected, and then you can control individually each one that you want to work with. So that's the way it works in Source Express. So right now I'm just using a virtual generator. I've found these other generators that are actually connected through the Ethernet using this connectivity tool here. Just by putting in the IP address and then doing a search, it will find the instrument on the bus. To create a virtual instrument, you would go under connectivity and you would create a virtual AWG, and this allows you to create an AWG with all the options that either you have or you don't have, so that you can simulate the AWG that you have in your lab. So as you see here, I'm under the Waveform plugin tab, and under this plugin tab is where we'll be introducing generation tools. And so right now I've got the basic waveform generation tool being shown. What I want to do is go ahead and select HighSpeed Serial. As you can see here, these are the 4 tools that are available, or plugins that are available for waveform creation. And so we'll talk about HighSpeed Serial to begin with today. So the HighSpeed Serial plugin, our new method of doing Serial Express. So this plugin allows you to create a specific types of signals that are used in serial data applications such as USB 3.0. We support SATA, some HDMI signals. Other new types of high-speed serial are also available, such as PAM4 generation. So in this case, many customers want to create jitter profiles that enable them to test their receiver in the worst case conditions. So using an AWG to create specific test environments such that you have a certain amount of jitter, a certain amount of ISI, a certain amount of random noise, a certain amount of random jitter, and in some cases spread spectrum clocking is also required to be tested in these high-speed serial standards. So the high-speed serial plugin allows you to do all of this within the plugin, create the waveforms needed, and then send them to the AWG. So as you see here under the basic settings, under the pattern is where I'll start with. We have the capability of using PRBS type patterns. You can use a clock pattern if you just want to create a clock type signal. You can do all zeros, all ones. An idle state would be something that is required in the sense that you don't want an output during a certain portion of your waveform, so you can create idle states. And then, like I said, we do have PRBS. We can go all the way up to PRBS 31 since we have enough memory to do this. And you can also create a user-defined PRBS. Pattern would allow you to create specific patterns so that you can put in your 100 or use binary, hex, or symbol. If you use symbol type characteristics, then you can actually go in under your modulation and create encoding that would be 8B10B encoded for that type of signaling. So we give you all the capabilities in here. Let's just start with, I'm going to use a PRBS 15 to start with here. You specify the data rate that you want to run the serial data signal at, invert the bits. You can also specify the amplitude. This amplitude, in most cases, you'd want to keep at max unless you want to reduce your resolution. With the max amplitude, you'll be using the full 10 bits or 8 bits if you're using markers of waveform capability. So in most cases, you don't really need to mess with the amplitude unless, like I said, you want to reduce it lower than required for this particular test. So this is under the basic settings. So once you've specified what type of waveform you want to do, also under here you can load a file. So if you have a specific lone bit type pattern or other types of patterns that are used in specific compliance testing, you can load that from a file and then use that as your basic pattern for your generation. So under the encoding modulation, in most cases it'll be an NRZ type waveform. It is possible if you want to do an NRZ minus I, or like I mentioned, you can also do PAM waveforms, and we support up to PAM 16 type PAM waveforms. Also, because of the AWG architecture, the PAM signals can be DC biased however you want, so that you can create anomalies that will may affect your receiver, so that you can test your receiver with your DC biases of your PAM4 signals at different levels. So this is also a nice feature that we've added to our plugin. If you need to do scrambling, we also give you the capability of doing scrambling. As you notice also, each time you turn on one of these features as part of the waveform creation, you'll notice that an LED comes up and shows you that that feature is on, so that when you're in any of the settings, you can see that, oh, I've got scrambling on. I may not want scrambling on, so at least it gives you an indication that that mode is enabled. You turn it off, and then of course you won't see that through the whole application. We also give you the capability of changing your step response. In some cases, some of the compliance standards require that you specify exactly what the step response to your rise time is going to be, either in 2080 condition or a 1090. So this gives you the capability of either doing it a first order type of shift or a linear shift. So first order would be more of a step condition, where the linear would be point to point for the samples. We also allow you to incite create duty cycle distortion as part of your waveform, and we let you specify that either in UI, or if you right click, you can change that to seconds. So this gives you the capability of, depending on how you want, and basically all of the inputs you can put in either UI or in time. We also give the capability of using the markers. For each channel, you have up to 2 markers on our AWG 70,000 series. So you can specify that maybe you want to use the marker as a trigger for a sampling scope or some other instrument. So you can specify that it's going to use the base pattern that you created as your marker, ones and zeros. Of course, you won't be adding any jitter to these base patterns, because markers are basically a logic state of 1 or a 0. You could also specify as just a clock, and you can specify the data rate of that clock as either a subrate of the actual data, or you can create your user-defined in frequency. You can specify it to where it's just high or low, so all the marker's high all the time, or it's low all the time. And then you have the same capability for both of the markers that are available. If you turn off in the AWG setup, you can go in and under the channel, you can specify whether you're using 10 bits or 8+2. And so you have to make sure that when you do run the AWG, that you're either running, if you're using 2 markers, then you do 8+2. If you're only using 1 marker, then you do 9+1. This is the basic pattern configurations that you have for the basic setups. So I'm not going to turn on any of these at this time. So under the transmitter tab, we have the capability of adding up to 4 different periodic jitter components. And again, you can specify these either in UI. In most cases, specifications are written in UI, or in some cases they are specified in seconds. So you can specify that either way. You do have a phase relationship that you can adjust, so that if you have for some reason need to change the phase of the waveform of that periodic jitter, you can do that. And like I said, we have up to 4 available. And then you specify the frequency of the actual jitter component here in the frequency tab. And you can also specify if you want it in integer cycles rather than it arbitrarily creating the waveforms as they need to be required for the particular jitter component. So this is a periodic jitter, so we'll go ahead and leave that. I didn't change any of the values, but you can see that we have quite a capability. If you set it for max here, you can see how high you can go. If you set it for min, then you can see how low you can go. Same for all of the inputs. So we can also add a random jitter as a component of the jitter, and you can have all of these on at the same time, or you can have one or the other on. So here we have the capability of adding 3 components of RJ, and in some cases you can specify the on RJ1 you can specify the actual seed of the RJ component, and you can also specify a specific crest factor so that you can test it depending on where in the actual random noise crest factor location, so that you can test at specific crest factors rather than testing through the whole range of the random jitter. So this is useful in cases where you know there's an area of your device that may have issues at specific crest factors. You can specify that in the actual waveform creation. And like I said, you can have up to 3 different RJ components. We also have noise. Now RJ will be limited to the total J characteristic, or random jitter characteristic would be limited to the record length that you're using for the randomness of the actual content of the signal. So we do enable up to 16 gig of waveform memory that enables you to have fairly good crest factor on these waveforms, but in some cases you may not have enough random jitter for the specific application using an AWG because of memory restraints. The noise is in the same capability. Again, you can specify near or far end noise, and whether you want what the magnitude would be, and if you want a single tone or if you want full bandwidth. So this is also used in many types of compliance testing. We also provide the capability of doing preemphasis. So you can specify up to 5 taps of preemphasis. So if we turn this on, you put in a value, and then if you preview it, you can see where the actual preemphasis will be. And again, you can go up to 5 taps of this capability. You can also use, if you use a fractional component or the linear component, to be able to create the preemphasis specifically as you want. Now, if you also want to do pre-shoot with preemphasis, then you're limited to only 1 tap of the preemphasis and 1 tap of the pre-shoot. So this works a little bit differently than preemphasis. But anyway, this gives you the full capability of creating preemphasized signals. Anyway, you can go in and add the preemphasis that you want. Okay, and then we also have the capability, I'll go ahead and turn this off, the capability of doing spread spectrum clocking. This is also required in many serial standards, so that you can use a triangular type or a sine type of shape, and you can do it up or down or unequal. Then you specify the deviation, and the specific error option gives you you can change the DFDT component of this or the location. So this gives you a complete flexibility of the spread spectrum clocking feature. So go ahead and turn that off, and I'm gonna just leave this. So under channel, this is a very complicated section. This allows you to use intersymbol interference, or ISI, and you can specify the ISI as a specific value. So in some cases you have a cable that's being used and it has a specific ISI. You can just dial in that ISI rather than having to add a cable to your network of your connections between your AWG and your device under test. So this removes some of the requirements of having extra hardware as part of your testing. Now, in many cases, instead of using ISI, customers would want to use S parameters instead. So S parameters would be a file that would be taken using a network analyzer or a file provided by a component company. So this is very useful in many cases where you have other components that you're going through from your AWG to your actual device under test, or in specific compliance standards, there is a specific S parameter that is required to be used for that particular application. So you can specify the particular S parameter. And we support up to 12 ports. In this case, this 12 port allows you to select your aggressor signals of what type of aggressors you want, or you can specify your victim signal. So this allows you to give you a complete capability of doing these S12P type files. In most cases, most people would use a S2P type as a differential capability. So here we can provide an S parameter file that's an S2P, and also we have the capability of cascading S parameter files. So if you have more than one component in your cabling network, you can put in all this S parameters of the components that are being used, so that then you can create the waveform to enable you to correct for all of these losses. So this is a very handy feature when you have more than one S parameter. And again, you have the capability of specifying each of these have to be of the same type. Now we also have the capability of de-embedding, so that you can de-embed the signal so that then you could send it to a scope, or to look at what the waveform actually is going to be looking like if you need to emphasize or compensate for it on the other end. So you could create your filter network to resemble what the de-embedding signal looks like. This is also a very, very useful feature. The other nice capability is for margin testing. So here's the batch mode. It allows you to specify the specific range, high-low, the increment, the start and end increment or amplitude. So it gives you all of the capabilities of building a very complex set of waveforms that then can be used as a margin test for your device under test. And then under the compile menu, we have the capability of, you can specify your corrections as part of the compilation. So when you create the waveform, it will actually add the corrections to that. This would be using the pre-compensation utility that we have available to compensate for losses from the AWG output to your device under test. The other thing you can do is, if you have a sequence, I don't have a sequence up right now, but if you had a sequence, you could have it automatically add to the end of the sequence the new waveforms that are being created with your batch compile or with your single compile. So this gives you quite a bit of capability. You can also specify how many times you want this pattern to repeat. In most instances, you would do an auto repeat count. This will guarantee that you have correct wrapping of your waveforms for the particular signal that you're creating, and that you're not changing the frequency content by too much. That's basically the features that we have available of our high-speed serial data application. So you can download this, as I said, as a free 30-day trial. You do have to license it as a 30-day trial. You can run it in, if you don't have an AWG, you can run this in our Source Express software, which is a free download, which is what I'm using right now as the Source Express software. So I think that I've covered most of the applications here. Once you compile a waveform, you then basically load it on your either into a sequence, or will automatically load into the channel that you want to run it on, and then you're ready to just start playing the waveform and then doing your testing. In some cases, it's very handy under this compile menu to be able to add to an existing sequence. For instance, if you're trying to get a device into loopback, usually you have some state machine patterns that are part of that sequence that gets the device into loopback. And all you want to do is add waveforms to the end of that set of steps that gets the device into loopback. So that's what this would do. It would add to the existing sequence the new waveforms you're creating. That way you won't have to create a whole new sequence with the state machine patterns that are used to put the device into test mode. So this is a very handy feature that we've added for the plug-in modules that we have available. So hopefully you'll be able to play with this and very effectively build high-speed serial data waveforms for your testing. Thank you.